Ever wonder why a bell curve's peak is so significant? This is a question that has intrigued mathematicians, statisticians, and data scientists for years. The bell curve, also known as the Gaussian distribution or normal distribution, has a unique shape due to the random variables it represents. This peak, the highest point of the curve, is the representation of the mean or average of these variables. But why is this peak significant? Well, in the fascinating field of statistics, the peak signifies the highest probability. It is essentially the center point of your data set where the majority of values fall. This is why it is sometimes referred to as the middle or center of the curve. The peak can provide invaluable insights about the set of data that you are dealing with, such as the average value and the dispersion of data points around this average. Understanding the peak of the bell curve can also help to identify outliers or values that deviate significantly from the average. Outliers can sometimes indicate errors or abnormalities in data, which can be crucial to recognize in fields like quality control or financial forecasting. Now let's pivot to the Greek letter sigma. Why does sigma, a symbol used frequently in mathematics and statistics, have such a close relationship with the bell curve? Sigma symbolizes standard deviation in statistics, a measure that tells us how much a set of data deviates from the average. In the world of the bell curve, sigma plays a crucial role. Theoretically, within one standard deviation, or one sigma, you'll find approximately 68% of all data points. This percentage increases as we move to higher sigmas, with about 95% of all data within 2 sigmas, and nearly 99.7% within 3 sigmas. This relationship between sigma and the bell curve is not just theoretical but practical as well. It is used extensively in quality control processes, financial risk management, and scientific research. Sigma and the bell curve together form the basis of many statistical models, allowing us to predict outcomes, identify trends, and analyze patterns. So next time when you look at a bell curve, remember the significance of its peak and the crucial role of sigma. These aren't just mathematical curiosities, they are fundamental tools in the world of data analysis and decision-making. Well, the explanation lies within the intriguing world of sigmas and normal distribution. Sigma, in the realm of statistics, is a symbol representing standard deviation, a concept that measures dispersion. This powerful symbol, sigma, is more than just a mere character. It's a representation of how data points can vary from an average value, which in statistical language is often referred to as the mean. This Greek letter, a symbol that looks quite distinctive, plays an essential role in the study of statistics, a field that is all about data and making sense out of it. The concept it signifies is termed standard deviation, which can sometimes be a difficult idea to grasp. But it's crucial to understand because it helps to reveal the characteristic of the data under consideration. Standard deviation is a measure that quantifies the amount of variation or dispersion in a set of values. It helps statisticians, researchers, scientists, and even business analysts understand how data points are spread out from the mean or the average. It provides an insight, the volatility, reliability, or predictability of the data. Now, you may wonder what it means when we talk about a low or high standard deviation. A low standard deviation indicates that the data points tend to be very close to the mean. In other words, the values don't deviate too much from the average. This might be the case when the results of a survey or an experiment are consistent, or when an investment's returns are stable over time. On the other hand, a high standard deviation communicates the opposite. It suggests that the data points out over a wider range. They are dispersed far away from the mean, indicating higher variability or volatility. This could mean that the results from a survey or an experiment vary widely, or an investment's returns are highly volatile, leading to higher risks. So the concept of standard deviation, as explained by the symbol sigma, is a fundamental concept in the field of statistics and data analysis. It's an essential component of understanding how data is distributed, whether it's for conducting a scientific experiment, analyzing business trends, or even making investment decisions. A low standard deviation means data points are close to the mean, while a high standard deviation indicates that the data is spread out over a wider range. Now, imagine a bell curve, a statistical model frequently employed to represent normal distribution. It's a fascinating concept, one that allows us to graphically interpret large volumes of data, making it easier for us to grasp the meaning behind the numbers. If you picture it, you'll see this beautifully symmetrical curve, almost like a perfectly rounded mountain peak. This curve, at its very essence, is a visual depiction of how data is distributed within a specific set. This set could be anything: heights of people in a city, weights of newborns in a hospital, or even the scores of students. The bell curve is an impressively versatile tool, capable of elucidating patterns in a wide array of scenarios, making it a favorite among statisticians, researchers, and data analysts worldwide. The curve culminates at the very top in a peak, a key point that is of considerable importance. This peak of the bell curve is representative of the mean, or as it's commonly referred to, the average. In other words, it's the point of balance, the value that essentially divides the data set into two equal halves. It's an integral part of the curve, and it's essential to understand what it represents. The mean isn't just another number, it's a summary, an encapsulation of the entire data set. It's where the majority of the values lie, or the most typical value you might expect to encounter. However, the bell curve offers more than just a representation of the mean. Just as important is the width of the bell. It's not arbitrary. It's determined by a crucial statistical measure known as the standard deviation. This is where our friend sigma comes into play. Sigma, the Greek letter used to denote standard deviation, is responsible for the spread of the curve. It indicates the extent of variation or deviation from the mean in our data set. A larger sigma would mean a wider bell, indicating greater variability in the data, while a smaller sigma suggests less variability. This balance between mean and variation is what makes the bell curve such a powerful tool for data analysis. So there you have it, a detailed dive into the inner workings of a bell curve. This curve shows how data is distributed in a set, with the peak of the bell representing the mean or average. The width of the bell, however, is determined by the standard deviation, our friend sigma. The relationship between sigma and the normal distribution is utterly captivating. In the realm of statistics and probability theory, the normal distribution, also known as Gaussian distribution, assumes a pivotal role. It is a vital concept, an integral part of scientific research and data analysis. To understand the sheer significance of this concept, it's important to delve into the basic foundations. Let's consider the relationship between sigma and normal distribution. The term sigma is an eminent statistical figure. It is commonly referred to as the standard deviation, which is a measure that quantifies the amount of variation or dispersion in a set of values. It gives us an idea of how much the data points deviate from the mean or average. Now, in a normal distribution, which is a probability function that describes how the values of a variable are distributed, it is a bell-shaped curve that is symmetric about the mean, showing that data near the mean are more frequent in occurrence than data far from the mean. Here enters the fascinating relationship with the sigma. In a normal distribution, about 68% of the data falls within one standard deviation or one sigma of the mean. This might seem like a mere statistical term, but it carries a profound significance. We use this rule to understand the data better and draw meaningful insights. The story doesn't end here. Approximately 95% of the data falls within two sigmas. This is not merely a statistical fact, but it's a cornerstone of many scientific studies, research, and statistical models. This information helps us understand the dispersion of data, and it is critical when we need to make predictions or forecasts based on this data. Finally, we reach the point where nearly all the data, about 99.7%, is within three sigmas. This phenomenon is the bedrock of the empirical rule, or the 3 sigma, which provides a quick estimate of the probability of a certain event in a normal distribution. It's an important tool for risk assessment and statistical forecasting. This phenomenon is known as the empirical rule, or the 3 sigma rule. The journey from the normal distribution to the empirical rule is full of intriguing realizations and insights. It's not just about numbers and graphs, it's about comprehending the world of data around us. To summarize and reflect on our discussion, sigma, famously recognized as standard deviation, does the critical job of measuring the dispersion of data points. This mathematical tool provides an insight into how much variation or dispersion from the average exists. The broader the dispersion, the higher the standard deviation equates to a higher sigma. On the other hand, we have the concept of the normal distribution. This concept, pictorially demonstrated as a bell curve, is an essential tool that shows us how data is scattered within a dataset. It is the most well-known data distribution graph used by statisticians and data analysts, and it typically forms a symmetrical arc. The peak of this indicates the most frequently occurring data points, while the decline on either side shows less frequent occurrences. The relationship between sigma and normal distribution is not just statistical, but is also incredibly fascinating. In a normal distribution, the majority of the data points, or approximately 68% of observations, lie within 1 sigma of the mean or the average. When we stretch this to 2 sigmas, we capture about 95% of the data, and at 3 sigmas, we have nearly 99.7% of all data points. This relationship is known as the empirical rule, or the 68-95-99 rule. Understanding these mathematical phenomena can be a game-changer in how we approach and decode data in a multitude of fields, from physics to finance, from environmental studies to economics, from healthcare to social sciences. It allows us to predict outcomes, identify trends, evaluate performance, and make informed decisions. But this is not just about crunching numbers and deciphering Greek symbols, it's about more than that. When we dive deeper into these concepts, we start to see them as more than just statistical tools. We begin to see them as a language, a narrative that paints a picture of the world around us. It's about understanding the story they tell about the world around us. These concepts help us read and understand this narrative, providing a new perspective on the fundamental nature of our universe. Thank you for lending your ear to this intriguing exploration of sigmas and normal distribution. Indeed, it's your inquiring mind that allows us to venture deeper into the absorbing realm of numbers and mathematical theories. It's the thirst for knowledge that helps us propel further into the mysteries that lie in the various disciplines of science. Today, we've navigated through the ocean of numbers, the ebb and flow of data points, the waves that form in normal distribution, and the significant role of sigmas in this enticing mathematical world. Its vastness can sometimes be perplexing, but it's the persistence of enthusiasts like you that enable us to dissect and unravel these complexities. Balancing on the tightrope and definite, we've jumped into the abyss of the unknown, only to emerge enlightened, armed with new knowledge. As we continue to traverse this labyrinth of numbers, we are reminded that every corner, every path, and every crossroad presents opportunities to learn, to grow, and to uncover profound insights. It's a world that's always evolving, always inviting, always perplexing, and yet steadfast in its rules and principles. This deep dive into sigmas and normal distribution is just the beginning of a thrilling adventure. As we pierce through the veil we uncover not just the laws that govern the universe, but also the beauty that lies within numbers and their patterns. We've only just scratched the surface, with countless mysteries still waiting to be discovered. Your participation in this journey is not just appreciated, but fundamental. It is your curiosity that pushes the boundaries of knowledge, that propels us forward in the quest for understanding the universe and its underlying principles. We invite you to join us again for upcoming episodes where we delve into the world of numbers, unearthing more secrets and fascinating truths. Remember to subscribe to our channel. By doing so, you will not only be supporting us, but also ensuring that you don't miss out on any future insightful content. Your subscription is a testament to your love for learning and your commitment to the pursuit of knowledge. Until next time, keep questioning and keep exploring.